Good morning, everybody. Sorry for the gravelly voice. I managed to catch something on the plane. The older you get, the more often you stand in front of an audience like this and you describe data that have been collected by other people. So the other people in this case are Oliver Hooker and Han Honkinen, who collected most of the data that I'm going to talk about. So what I'm going to talk about today is the spatial nature of variation in Scottish Arctic char. So we're changing species here. If I can make this thing work. Sorry, it's changing on the laptop but not changing on the screen. I need some help.
You want to do an interpretive dance here?
I could try, but I don't think the audience would stay for long.
And now we're doing the opposite.
It's working from this, yeah.
Okay, so let's do the down arrow. It won't change on the computer, but it'll change on the screen.
Okay.
Is that okay? Let's give it a whirl here.
Will it work from this?
There we go.
Okay. Is that going to work? Yes, brilliant. Okay, so what let me flip back again and remind you what I was going to start with. We're going to look at the spatial nature of variation in Scottish Arctic char. So I'm talking about phenotypic variation and genetic variation and the structuring of those two things. And I want to look at spatial scales, particularly over which we observe this intraspecific variation in Arctic char, Salvelinus alpinus, and I want to use examples from Scotland. And I want to particularly focus on the kinds of proximate mechanisms that may be maintaining this variation. So to get us into thinking about spatial scales, I thought I'd flip up a couple of diagrams that you're going to be very familiar with by now. If you don't know this is Lake Superior, then we're in serious trouble. But many of you might not know that this is Scotland. Interestingly, I found out last week when I was thinking about this, that in fact you could, if you could, scrape up Scotland and drop it on top of Lake Superior, something like that. Then two things would happen. Firstly, Scotland would sink without trace and still leave 2,000 square kilometres spare in Lake Superior. The second thing that would happen is that Scotland wouldn't get much wetter than it is at the moment. The point I'm trying to make is Lake Superior is a very big lake. Scotland's actually quite a small country, and the data I'm going to show you just now over the next few minutes is from Scotland, a small country, and that's important. Despite that Scotland's a small country, we actually don't know where the Arctic char are. We know a bit more than we did a few years ago, partly because of this man, Peter Maitland, who quite some years ago started collecting records of Arctic char in Scotland. And he, with some help from me, have now compiled these into a volume. We found 1,413 records, the earliest being from 1610, and we now know something of where Arctic char are in Scotland. These red dots are records of Arctic char populations, 295 populations which have records. But only 141 of them would be regarded as really robust records where we're fairly certain that we know that there really are Arctic char there. There's clearly a lot of underreporting. There's clearly a very large number of populations in Scotland that we just don't know anything about, that we just don't even know where they are yet. Interestingly, though, very few extinctions, very few records of extinctions from Scotland, only 9 extinctions, and all of those really from the south of the country, and that's given me the opportunity to remind you that at sea level, Arctic char in Scotland are at the southern end of the range. They're right at the end of where you can find them surviving at sea level. A relatively small number of introductions into Scotland, 18. Some of those have been for conservation reasons. A lot of them have been for just sort of reasons of whimsy, landowners bringing Arctic char into their particular patch and releasing them. Vast majority of those introductions have not survived any length of time. But But the main point of what we're going to be talking about today is really the fantastic phenotypic variation that we see across Arctic char. All of these photographs are from Scotland. They're all Scottish char. The amount of phenotypic variation that's staring in the face just in this slide is really quite astounding. The vast majority of that variation, of course, is discrete populations in different lakes that are not mixing, so they don't have access to each other because there are no, as yet, unknown, there are no known anadromous populations of Arctic char in Scotland, so there's little opportunity for gene flow between one freshwater lake population and another. But the phenotypic variation that we see in Scotland is more complex than that. It's more complex than just different populations showing different phenotypic characteristics. And there's a couple of places where we've been looking within single catchments, where there are multiple lakes, where we've been looking at the phenotypic variation between populations in different lakes. So here are 3 that we've looked at, comprising in total 8 lakes. There's a catchment barrier there, that's a watershed there, so this system drains to the east, this system drains to the west, this system drains to the east. There's 3 lakes in this one, 2 in this one, and here's another set of lakes with 3 populations of Arctic char in them. The Arctic char in each one of these lakes is morphologically different. We can detect very clearly the differences between populations are based on morphology alone. Looking at selection neutral microsatellites, we can discriminate between all of these populations. They differ, the vast majority of them differ in terms of their foraging strategies. They have different foraging strategies in different lakes. There's also all sorts of other characteristics like growth rate differences. But the important thing is that they're reproductively isolated from each other. They're not sharing genes, despite the fact that we know that fish can move up and down these catchments. Atlantic salmon and anadromous brown trout move up and down these catchments very simply and very easily between one lake and another. Arctic char are perfectly capable of moving between different lakes. They're just not doing it. The other kind of structuring that we see amongst Arctic char in Scotland is where we have genuinely sympatric polymorphisms, and we now know we've got well-described sympatric polymorphisms in 8 sites in Scotland, and these dots show where they are. We tried to make an estimate of how many populations might have sympatric polymorphism, and we think we've probably looked at enough populations carefully enough to reckon that about 15% of lakes are supporting sympatric polymorphisms in a single lake. That may be a slight underestimate, a slight overestimate, it's a rough guess, but the main take-home message is that sympatric polymorphisms are really quite common in Scotland. So what's maintaining this pattern of structuring? What is it that is helping this structuring maintain itself? Can we actually see some patterns? And I think we can. And the easy one is, of course, the populations that are in Parapatric, where you've got 2 lakes that are in discretely different catchments. Because there's no anadromy, the fish are separated, and thereby it's quite easy to see how you can end up with structuring in terms of phenotype and genotype. It could easily come by genetic drift over a period of time, or it could be that you're getting directional selection, pushing different populations in different directions. And for a number of reasons, we think that drift is there's no doubt about it, but we think that the vast majority of the differences that we're getting between populations has functional significance, and that suggests quite strongly a directional selection mechanism for driving different phenotypes in different unconnected water bodies. But of course that argument doesn't hold where you have populations which are in Parapatric or populations which are in Sympatric. You just can't invoke that argument. So what I wanted to do was just examine in a bit more detail 5 examples from Scotland and see if we can tease out what elements of those populations may give rise to at least maintaining the structuring that we can see now. and then I want to try and draw some general conclusions. These are the Parapatric populations, the 3 catchments where we've got lakes, each with Arctic char in them that I just showed you a minute ago. If you remember, I said they're reproductively isolated, they're sharing very little genes, and in fact you can model just exactly how many genes they're sharing per generation. And these numbers here reflect the effective number of migrants per generation between neighbouring lakes. So between this lake and this lake, it's about 2.1. Between this lake and this lake, about 0.6 individuals per generation. These are very, very small numbers indeed. The point I'm trying to make here is that there is just no gene sharing, even between populations which are very, very close together. We're talking about only a few hundred meters between this lake and this lake. We're talking about very, very strong structuring over very small spatial scales indeed. There's a scale bar there, 10 kilometers. The 10 kilometers would apply to about this as well. Some of these lakes, this lake and this lake are literally 100 meters apart. So what are the proximate mechanisms that are at play here that might be at least maintaining the structuring? Well, it looks like we've got spatial segregation. We've got spatial segregation between different populations, but that can only happen if we have very strong spawning site fidelity. In other words, if char in this lake are only spawning with other char in this lake and not spawning with char in this lake. And it seems like spawning site fidelity is driving the spatial structuring that's allowing us to, that's maintaining this phenotypic and genetic structuring over long periods of time. But the main point I want to make about that is that the spatial scales are tiny, very small indeed. And I find that very surprising. Second example I want to take is one that's been mentioned, it was mentioned by Anders Clementson yesterday. This is the sympatric polymorphism in Loch Rannoch. We have 3 morphs in Loch Rannoch, a benthivorous, a planktivorous, and a piscivorous morph. They vary in a whole bunch of things. I'm not going to list them, but they differ ecologically, they feed on different things, they have different body patterns, they're morphologically different. And Anders mentioned a paper from the Scottish Symposium where Eric Verspoor described how isolated reproductively they were. They are sharing almost no genes, if they're sharing any at all. So how does that occur? Do we know anything about it? Well, we actually know quite a lot about their spawning sites. The benthivorous form is a stream spawner, and it migrates up into only 2 streams as far as we know, on the west end of this relatively small lake. The lake's only about 12 kilometers in length. That's 15 kilometers in length, sorry, my apologies. What's happened here? There we go. It's about 15 kilometers length. It's only 19 square kilometers in surface area. The planktivore it spawns on submerged gravel beds in the littoral zone, and it spawns all along the south shore. The piscivore also spawns in the lake itself, but spawns in deeper water. And that spatial segregation seems to be enough to prevent the sharing of genes. We know that if you collect eggs and sperm in vitro and fertilize eggs with sperm, that they're perfectly viable. There's no impediment if there is in vitro fertilization. However, in the wild, we have not found hybrids. We don't know of any hybrids. It seems that this spatial structuring of spawning seems to be enough to keep the 3 morphs apart, and they have been apart over relatively long periods of time. We've known about this morph structure for 30-something years. But again, I want to remind you of the exceedingly small spatial scales that are involved here in creating or in holding this structuring, I should say. This can only work, the spatial structuring can only work, again, if there's very strong spawning site fidelity. If these fish migrate up these streams and this one doesn't start suddenly migrating up these streams, then the structuring seems to remain in place. The third example I wanted to describe to you is from another Sympatric population, in this time in Loch Awe, on the west coast of Scotland. We have two morphs. They differ ecologically, their foraging differs, they differ morphologically, and they have subtle but detectable genetic differences between them. This is stable isotopes data. You can see very clearly differences in foraging. The one morph forages at least one trophic level above the other. Carbon sources differ between the two morphs. This is morphological data. There are sex differences in morphology between males and females in both morphs, but there's also a clear morphological difference between morphs. So how is this maintained? How do we know anything about how this is maintained? Well, interestingly, in this case, we're getting temporal differences in spawning pattern. So one morph spawns in autumn, in October and very early November. The other morph is a spring spawner. And so in this case, it looks like the proximate mechanism that's at play is one that's temporal. There's no overlap in spawning time. There's actually, interestingly, quite a lot of overlap in spawning sites. They seem to spawn in the same sites, but just at different times of year. And again, the spatial scales are very small indeed. This lake is 30 kilometers long. It's a relatively narrow ribbon lake. Fourth example I want to touch on, again, is a sympatric polymorphism from Loch Tay. And interestingly, whatever is causing the structuring in Loch Tay is rather different from the temporal and spatial patterns that we've just seen. Loch Tay Arctic char come in two sizes. They're very large at spawning time, or they're very small, and there's no intermediate sizes. That's the size frequency distribution of spawning adults that you can see in front of you. You're either large or you're small. There's nothing in between. Morphology is, they differ in morphology. It looks like they differ in morphology quite dramatically, but actually once you take size into account, the morphology differences are clear but relatively small in magnitude. They differ genetically. They clearly don't share genes. They're very distinctly different genetically. And they do have differences in foraging, but their foraging niches do overlap a fair bit. Again, this lake is relatively small, 23 kilometers in length, surface area 26 kilometers. It's a small system. It's a small... I wanted to say something about the trophic ecology. There's data on stable isotopes, clear differences in foraging ecology, but not quite as distinct as you might imagine. Morphology, this graph, if you're comparing this graph to the one I've just shown you from Loch Tay, the scales are rather different. So the Procrustes differences between the morphs are relatively small compared to the Procrustes differences in morphology between the two forms in Loch Awe. And again, we've got sex differences here. So, what's holding apart? What is the proximate mechanisms that are holding apart this structuring that we see in Loch Tay? Well, actually, we don't really know. We don't really know because they're spawning at exactly the same sites and at exactly the same times. They have the same spawning areas. So, there's two possibilities. Either there's some kind of assortative mating which is resulting from mate choice. So females are choosing to mate with specific males that have belonged to the same morph category that they're in. Or alternatively, there is exceedingly heavy mortality on hybrids. Hybrids just don't make it. If there are crosses, the hybrids just disappear before they get to any size, and particularly before they get to sexual maturation. And we can't disentangle those two things. Although, personally, my money is on some kind of behavioural assortative mating rather than hybrids, because we've yet to find hybrids even amongst juveniles. But we do know that they are reproductively isolated, and we do know that the spatial scales over which this is happening are very small. The last example I want to give you is again another sympatric population, and this is actually the smallest of the sites that I've described to you so far. This is a very small lake. It looks like it's spelt Dougal, Loch Dougal, but it's pronounced Doul. It's a Celtic Gaelic thing. And the surface area is less than a kilometre. And we have two morphs in Loch Dool, which is in the far north of Scotland. The morphs are very easily separated on the basis of morphology. That's the frequency distribution of discriminant function scores. They separate out really very clearly indeed. Those are photographs of the two forms down at the bottom there. They differ very distinctly in where they can be captured during summertime. So there's a morph that's found very high in the water column, a morph that's found very low in the water column during midsummer. They're actually found at about the same depths and about in the same places at spawning time. So clearly one is a profundal morph, and I'll sort of emphasize that by giving you some data on the stomach contents. On the left-hand side here is the diet of the profundal form. They're really only eating two things. Basidium, which is a small deep water bivalve, and deep water chironomid larvae. So profundal form are really eating only that. The other form is eating plankton, and the plankton is dominated by Leptodora, it is. So we clearly have a pelagic form and a profundal form that differ substantially in terms of their diet and morphology and a whole bunch of other things. So Han and Oliver have been interested in looking at how this differential habitat use that they are picking up in gill nets, how does that pan out during the course of the year? And is it fairly constant? Are they segregating on the basis of simply depth? And how robust is that segregation? So what they've been doing is they began a study a couple of years ago looking using acoustic telemetry techniques to attempt to try and work out how the fish were moving around these habitats. You've probably visited the Venco stand outside, so I won't bore you with the details, but thankfully we were using Venco gear, so I can hold my head up in this audience, just in case there's someone from Venco listening. We used V7 tags. They're 7 millimeters in diameter tags, but we also had a very small number of tags which also had depth codes. So we were able to position most of the fish. For 6 fish, we also had depth information. The depth information, we had to use a slightly larger tag to get depth information, so we only wanted to implant a relatively small number of fish. We went for a study design which meant plastering the whole lake with receivers, relatively small system, so we could afford to do that. 24 receivers, those red dots are telling us where the receivers are. That gives us the density of receivers meant that we had a very high probability of detection of any individual at any point. There was very few blank spots in the course of this study. The fish were tagged intra-abdominally, so it meant making an incision in the abdomen, placing a tag inside and sutures to then close up the wound. And these are the two forms, the pelagic form and the profundal form. They're about the same size in terms of body size. Very slightly, the profundal form is on average very slightly larger. What's interesting, though, is the very distinct difference in lipid concentration. About twice as much fat deposition in the pelagic form, feeding on plankton, than the profundal form. We had 5.2 million detections in the next 120 days. The pelagic form was on average detected at 18 of the 24 receivers. The profundal form at slightly more than that. Only 2 fish, we lost 2 fish because they migrated out of the system. Relatively few fish died, so we had a really quite a robust sample size. Tag life was 120 days, so we were getting good information for about 120 days. Interestingly, we were seeing enormous differences, individual differences in how they were using the lake, looking at it horizontally. Both of these on the left-hand side are pelagic forms. This individual actually concentrated on using just a tiny patch of the lake, whereas this one shot around everywhere, right across the lake. But that was also true of the profundal form. There's a profundal individual that actually just maintained itself only in one patch. This one moved right across the lake over the course of 120 days. I have, and I hope this is going to work, a little video. There we go. This is 1 week's worth of movement by a profundal morph. And you can see a very strange pattern. It was making quite a big leap from one place to another, and then spending a bit of time actually circling around in that area. But in the course of a week, this particular individual covering quite a lot of the lake. Oh, that's not what I meant to do. Okay, so when you look at averages, the mean daily distance moved per fish, all fish were moving quite a long way, 3 kilometers on average for the profundal form and about 2.5 kilometers for the pelagic form. Not surprisingly, the amount of movement started to decline during the course of the summer and into the autumn. So this is the total amount of movement over time, declining down towards the winter. And a surprise to me was that the profundal form, its home range, was statistically significantly larger than the home range of the pelagic form. We tend to think of plankton feeders as being constantly moving, and indeed the plankton feeders in the study were constantly moving, but they were moving less than the profundal form. We kind of tend to think of profundal feeders as probably not moving around all that much, but in fact it was the other way around in this particular study. But what's really interesting is just how restrictive in terms of depth various individuals were using the water column. So these are data from 4 specific individuals over about 100 days. You can see that the actual depth movement is very, 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 very narrow. They're only moving 5 or 6 meters up and down through the water column over 120 days, 100 days or thereabouts. So that's the pelagic form. This is quite close to the surface, so that's about 5 to 10 meters in depth, I think that is. This particular individual was very close to the surface, so hovering around just that 5 meters, the top 5 meters. And as you might expect, the profundal form in much deeper water, this one in very deep water, this one in slightly less deep water on average. But enormous consistency in terms of the depth zones in which these individuals were using the water column. So I've just got 2 slides left. So what are we trying to get from this? Well, the telemetry from Lough is telling us that the profundal and pelagic morphs are indeed profundal and pelagic. They're occupying those habitats, and they're occupying those habitats with very little variation, unlike the talk we heard this morning where the lake char were moving up and down through the water column. These guys are not. They're once they get to particular depth, they're staying there for very long periods of time. So how is this polymorphism maintained, to get back to the basic question? Well, again, we don't know. We do know that they're spawning at the same site and they're spawning at the same time. And so we're left with the 2 possibilities that we had for Lough Tay, and that is that either there's very strong assortative mating, and that assortative mating is based upon female mate choice, or the alternative is that there is hybridization, but the hybrids just don't make it. In actual fact, at this site, we have found some hybrids, a very small number, but we found about 3%, something like that, of hybrids, and the hybridization has all gone in one direction. So interestingly, there are some hybrids, but those hybrids seem to be behaving like the pelagic form. So, of the 5 examples we've got, 2 of them, we seem to have the polymorphism, the structuring maintained by some kind of spatial segregation with some natal site fidelity, so there's homing back to the natal site. For one, there's temporal differences in spawning, which seems to be the proximate mechanism that's holding the 2 morphs apart. But for the other 2, there seems to be no temporal or spatial segregation, so we're left with 2 possibilities, either mate choice or differential mortality, very high differential mortality of hybrids. That's all I've got for you. Thank you.
Thank you so much to all of our speakers. We're actually out of time. So if folks have questions for Colin, I encourage them to go up to him at the break, and we will be meeting back in 20 minutes.